Hello, my name is Warren Young. This is Tangent Tutorial 7, Creating Schematics in Eagle. In this tutorial, I'm going to introduce you to Eagle, starting with a schematic for this Adapt TLE circuit. And all it does is it takes this TLE2426 part and converts it from this surface mount pinout to the 3-pin layout that you see right here, and so it will add a capacitor to one of its pins. So it's a simple conversion board. So it'll provide a real gentle introduction. So I'm on the Mac right here. There's only a few small differences among the three platforms that Eagle supports. On the Mac side, the only trick is that when you unpack the package, it's just going to expand it right in place into a really ugly folder named with the version number and other things. I renamed that instantly to Eagle, and then I drop that into my application folder. On the Windows side, it will just set up the program icons for you. On the Linux side, it actually behaves most naturally because that's kind of where it comes from. And then on the Mac and Windows sides, it tries as best as it can to fit into that environment. So I've drilled down into the bin folder on the Mac side, and then I can run the program. Like I say, on the Windows side, you just pick it out of the Start menu, and then on the Linux side, it behaves wholly differently. Now, once you're inside the environment, the platform differences become much smaller. So the program looks the same on all the platforms. So I'm going to go here into projects, and I'm going to say new project. And what I've done is I've right-clicked on it. You can actually say file new project. That will work too. And I'm going to say adapt TLE. Just name it after that. And this is actually creating a folder underneath the Eagle folder, which it creates in your home folder. So it's your home folder and then Eagle and then whatever it is you've called it right here. So there's other ways you can arrange your projects, but we're not going to go into that, so we're going to take you through the standard way of organizing your project. So I'm going to right-click on this again, and I'm going to say New Schematic. Now, I'm on a Mac, and yes, I did just say right-click. If you have one of Apple's one-button mice, go get a 3-button mouse. I will wait. Go get one. If you're on the Windows side and you have just a 2-button mouse, not one with a wheel, but I mean just 2 buttons, go get a 3-button mouse. I'll wait. Okay, got a 3-button mouse? Good. Because Eagle is made for 3-button mice. You can limp by with 2 and 1-button mice. I've done it. It's not fun. Go get a 3-button mouse. We'll use, even in this simple little tutorial, we'll use all 3 buttons. The simplest thing you can do is you can say add, and that will open up the Eagle library. It's taking a while because it's loading up the entire Eagle library right now. And this thing is pretty huge. But nowhere in here will we find a TLE2426, and so I'm going to cancel out of it. What we're going to have to do is we're going to have to pull down the library menu and we go to Use. Now, by default, it pops you into the Eagle library directory, and we already have all these loaded up, so we don't need them. I'm going to go here into my home directory and into Eagle. This is just where I've put it. You can put it wherever you like. But I've got this TLE2426 library that I created. If you don't have this already, you might have downloaded it from my website already because it's been up there for quite a while. But if you don't have it, go up to my website into the Eagle parts section and you can go and download this library and then you can follow along. So by using this library, when I go back into Add, scroll down here, only one tiny little difference, and that is that the TLE2426 library now shows up. So it's not going to go and find your third-party libraries by default. So you have to use them in order to get it to find them. So I'm going to open this up, and I want the CD variant, which is the SO8, and I'm going to click on it, and now I've got the part attached to my cursor, and wherever I left-click, that will drop the part. Okay? I can put more of these on the board, but I only need the one. So I'm going to hit Escape, and that will take me back into the Add folder, into the library, on the theory that you probably want to add more parts, and indeed we do. We're going to come up here to the RCL library. You're going to become really good friends with this library right here. That's because this is the resistor, capacitor, and inductor library. So there are some manufacturer-specific resistors, capacitors, and inductors in the library, but for the most part you want to use these, which are the generic versions, because most resistors, capacitors, and inductors don't have a special pinout. They're generic. So we're just going to use one of these. I'm going to go here into the CUS one, which is the non-polarized American capacitor symbol library. There's a variant here for European symbols. It has the same parts in it. The only difference is this symbol, so it has, you know, that symbol versus that symbol. There's also the polarized libraries, and so that's where the electrolytics and the tantalums would be, but we want the non-polarized capacitors. I happen to know already that I want this part right here, but if I wasn't sure, I can use the up and down arrows in here, and just kind of watching both the footprint and the description down here, I can find the part I want. And you can just see that you can just kind of scrub through here until you find exactly what it is you need. What I'm looking for here is I want one with a 5mm pin spacing, which is what grid means, and I need it to be about that wide for the size of capacitor I need. So that will do fine. So I say OK, and I can left click again. That will drop my part, and I could left click more times and get more of these parts, but I only need the one. So escape takes me back into the library. I'm going to scroll down here to the surface mount parts, and then I need this 1206 size part. There's two variants of this, and the only reason you care which one to use would be if you're having your boards professionally manufactured and stuffed, and the manufacturing people might tell you, I want this one or I want this one. But when you're DIYing, it probably doesn't matter which one you choose. And I'm going to put it right beside it because I want it to be in parallel with the other one. So escape takes me back into the library, and jumper is where I want the next part to be, and this is, I want the JP2E. So this is a standard 3-pin 100mm jumper block. You've seen these on probably all kinds of electronic parts. They're the big square pinned jumper blocks. They're used on computer motherboards and that sort of thing. They're just bog standard common. So I'm going to drop this down, and I'm going to put it down here. Now this is kind of a schematic tip. If I come back to my board, I know that I want these 3 holes to be along the bottom edge, okay? And so since I don't have a better place to put it on the board, I'm going to put it down on the schematic just because that will work logically. I could put it up here and the schematic will still work, but it won't be obvious why it's way over here and up and to the right. So that's just a kind of a logical place to put it. So you want your schematics to flow in some logical fashion, because schematics are first and foremost for the human. Create them so that they're readable first, and then so that they work for the tool second. So I say escape, takes me back into the library. I'm done adding parts, so I say escape one more time, and that will take me back into the Eagle schematic editor, and I'm now out of add mode. And so now I can do something else, and the thing I'm going to do is I'm going to say net, which is how you connect parts together. So I'm going to click on this pin 8 on the TLE, and at this point I now have this wire, a net, which I can connect to another pin. And I'm going to just drag it right down here, this C1. Now, I click on the other pin, and now I've got another wire, and this one needs to come up here to this pin too, but I don't want it to have such a sharp bend. I need it to have a little bit more room for things I'm going to do later. So one way I could do this is I can click there on the corner, which will let me come back around here and click up there. So 2 clicks and that comes back up and gives me a little bit more room before it starts coming back up. I'm instead going to say DELE for delete. Oh, and by the way, you notice I've been using the command line instead of these icons over here in the menus. I can work a lot faster with the command line, and I suggest you start learning these commands. There's some things that are just so much faster to do, and once you start getting used to those commands, you can type them faster than you can find the menu. Reach over the right mouse or to the mouse and find the menu and pull it down and click it. It's just simpler to say DELE for delete. That's the other thing, is you can abbreviate commands, and so I think DEL will probably work too. And so I'm going to delete those 3 pieces of the net, and I'm going to go back into net mode. And so I showed you that I could go and I could click and click and click, and that will work. Another way you could do this is kind of watch that wire. I'm right clicking now, okay? And what that's doing is it's toggling among the bends, okay? You can watch up here as well, these icons will do it too, and you can click on them, but I find it simpler just to watch the wire while I right click until I get the bend I want. And so I've come down here, and so let's see, that's the bend it had before, which doesn't help me, but I want it to bend like that. So I come down here, click, and click. Okay, so that looked like it took more time, but when I'm not pausing to explain, I can do that faster than I can do it in other ways. So learning how to do that left and right click thing very fast, you can move along real quickly. So that's a left click until I come around there. And so I'm just adding these parts in parallel until I, so I'm going to click on this first one. Now, once again, it's bending around the wrong way, but instead of, so I'm just going to right click until I get it to bend the way I want, and then I'm going to come down and then left click. So you can see that getting it to bend in the right way is something you'll do again and again and again. And so learning how to get it to do that very quickly without going and fiddling with icons and buttons and menus, you can work a lot faster that way. So those left and right clicks, learn those, play with those. Now, we've got kind of a problem. I'm going to hit F3 to zoom in here, and I can hold down the middle mouse button to pan around. You can see that this wire comes down and it actually crosses the part until it connects to the pin, which is this thin part down here at the bottom. I want these pins to be up, and so I can say MOV for move, and I can rotate this around by hitting the right mouse button. Okay, so I can move it around and I can rotate it with the same tool, and now the wire is coming down and it's going straight to the pin, which is what I want. But I've got a new problem, which is that my pins are now numbered backwards. So I'm going to click on it again. I'm still in the move tool, so I can click on it again, and now I'm back to move. And now if I hit the middle mouse button, I've flipped it. Okay, and so middle mouse button will mirror it back and forth. Right mouse button rotates it, and then as I drag my mouse around, I can get it to come around into the way I want. So between those three mouse buttons and moving it around, you can quickly rotate and flip and move a part until it's the way you want. So now I've got my pins in the proper order, and the pins are upward the way I want. So very quickly I can fix its default arrangement until I get it to be the way I want it to be. So back into net mode, I'm going to take my third pin here. I'm going to come up and around to that pin 1, and finally off of this corner, I'm just clicking on that corner and come down to pin 2. So I've got my schematic arranged. It's a little loose right now, and so I'm going to say GRO for group, and I'm going to click and drag out a square around the things I want to move all together. So I've actually selected 3 things here. I've selected the jumper itself, I've selected this corner, and I've selected this corner. And so when you move a corner, you're moving, so I've got both corners of the wire, so I'm going to move the whole wire. So if I now say move, and then I right click, that will select the group and it will move that. So a left click will move just one part, a right click takes the latest group you've added and moves the whole group. So I'm going to put it right there, and I'm going to say group again, and I'm going to select these things, move, right click, move that up. So just a few clicks and a few commands, and I've tightened the schematic up a little bit instead of the looser version that I had before. Next step, I can go and I say val for value, and I can add values to these parts. 1 UF, these are 1 mic caps. I might choose to leave it off of this one, or maybe I can now say move and get a little bit of space in there between those 2 parts. I can click on this wire, this net rather, and move that out that way so I can get a little bit of space in here. Now, this part right here, I don't want it to be called U$1, so I say name. I can call this, say TLE, which is a logical name in this case. And then I don't really need it to be called TLE2426CD for the part name, because there's only one and it's such a simple circuit. What I want to say is I can say val, and although this part right here doesn't have a value, as it's complaining here, it will give you the part name instead. And so I can delete that out and now have just the TLE. Now, the label is way up and to the right, and I would like it to come down a little bit. And so how do I move just this label? Well, what I have to do is I have to smash the part, and SMA is a good enough abbreviation, but you say smash, and you saw this crosshair up here. What that's doing is it's breaking apart the labels from the part itself. And so I can now say move and move this alone. And you see that wire there connecting the part. So if I'd managed to drop the label way up here and I didn't realize which of these parts it belonged to, I can click on it again and it'll tell me it belongs to that thing over there. Let's say that I find that, okay, so let's say I say that that's too close, or too far away, and that that's too close. And there's really no way on the grid that I can make this, you know, none of these positions really make me happy. What I can do is I can say grid, G-R-I, or grid, and I can change this to a half-size grid. Okay, and now when I say move, I can move this in a much finer increment to something like that, and that might be, you know, more what I want. But one thing you want to do is say grid last. That will take you immediately back to the grid you were just barely using, which is the standard 0.1 size Eagle grid. You don't want to be off of that 0.1 size grid for too long, because if you end up placing a bunch of parts on a different grid, Eagle will sometimes have trouble connecting parts up to each other because it kind of depends on that 0.1 size grid. So when I need to move something on a finer pitch like this, I'll pop into that one grid, move it, and then immediately come back with the grid last. If I say it again, grid last, that will take me back to, let's just show you, I'm now back to this right here. Grid last is essentially pressing this button for me. So instead of saying grid and opening the dialog and saying last, it's just simpler to say grid last and pop back and forth between the grids. And you can actually see it changing over here on. So you can see the grid size changing immediately. So that's one of those examples of why learning those commands can allow you to move much faster. So we've got our schematic done. In the next tutorial, I will show you how to take this and create a circuit board from it. Thanks for your attention, and goodbye.